We now discuss 6 multiple choice questions from the section Sequences. In the January 2024 session of the JEE Main Examination, 13 questions were asked. 13 multiple choice questions were asked under the section Sequences and Series. In an earlier video, we have done 7 multiple choice questions, and the remaining 6 multiple choice questions we are now doing today. These examinations in the January 2024 session were held from 27th January 2024 to 1st February 2024. Now this is the 8th question, and the question is on the topic geometric progression. This question has appeared in the joint entrance examination main held on 30th January 2024 in the second shift. The given question is, let A and B be 2 distinct positive real numbers. Let 11th term of a GP, whose first term is A and third term is B, is equal to pth term of another GP, whose first term is A and fifth term is B. Then P is equal to. We are given 4 options. So we are given 2 distinct positive real numbers, A and B, and there is a first GP, geometric progression. The 11th term of a GP, the first GP, is equal to the pth term of the second GP. For the first GP, the first term is A and the third term is B. For the second GP, the first term is A and the fifth term is B. And it is further given the 11th term of the first GP is equal to the pth term of the second GP. Then required to find the value of P. Let's now discuss the solution of the problem in detail. Given A and B are both positive real numbers, we have 2 geometric progressions. First, we consider the first geometric progression. Let us say R1 be the common ratio of the first GP. For the first GP, it is given first term is A and third term is B. So given T1, term 1 is A, third term is B, T3 is equal to A R1 square is equal to B. It is a GP. Therefore, these two will imply R1 square is equal to B by A. For the second GP, let R2 be the common ratio for the second GP, and it has the first term A, T1 is A, and the fifth term is B, that is T5 is equal to A R2 to the power of 4 is equal to B. From these two, we get R2 to the power of 4 is equal to B by A. Here, R1 square is equal to B by A for the first GP. For the second GP, R2 to the power of 4 is equal to B by A. So we are given the 11th term of the first GP is equal to the pth term of the second GP, required to find the value of P. The pth term means A R1 to the power of 10 for the first GP is equal to the pth term A R2 to the power of P minus 1. So this will be A into R1 to the power of 10 is B by A to the power of 5 because R1 square is B by A is equal to A times R2 to the power of P minus 1 is R2 to the power of 4 is B by A. R2 is B by A whole to the power of 1 by 4. And R2 to the power of P minus 1 will be B by A to the power of P minus 1 by 4. A cancels on both sides and the bases are B by A to the power of 5 is equal to B by A whole to the power of P minus 1 by 4. Bases are same, therefore the powers must be equal. That will imply P minus 1 by 4 is equal to 5. P minus 1 is equal to 4 5s are 20. Cross multiplying, P will be equal to 20 plus 1, that is 21. So we are required to find the value of P. Thus we got the value of P is equal to 21. So let's look at our options. Our answer P is equal to 21 appears against option 3. Therefore, the answer to this question is option 3, and that is the detailed discussion of the solution of the given problem. I am sure that you have understood the solution of this problem. Now we move on to the next problem, that is the 9th problem, and it's again from the section Geometric Progression. This question has appeared in the Joint Entrance Exam Main held on 31st January 2024 in the first session. The given question is 0 less than C less than B less than A. Let A plus B minus 2C in brackets x square multiplied by x square plus in brackets B plus C minus 2A multiplied by x plus in brackets C plus A minus 2B is equal to 0. Is a quadratic equation. So and alpha not equal to 1 be one of its roots. Then among the two statements, statement 1, if alpha belongs to open interval minus 1 to 0, then B cannot be the geometric mean of A and C. Statement 2, if alpha belongs to open interval 0, 1, then B may be the geometric mean of A and C. So the 4 options are given. So that means you know how these statements both are true, neither nor, 1 is true, 2 is not, 2 is true, 1 is not. So all those combinations are given here. So you are given 0 less than, C less than, B less than A. You are also given this quadratic equation and given alpha not equal to 1 be one of its roots. Then from these two statements, how are they? So are they both valid or none of them valid? So one is valid, the other is not. So you have to discuss all those combinations. Let's get into the problem. We now discuss the solution of the problem in detail. Agreed. Given 0 less than, C less than, B less than A. This is important because when you want to talk, some of the factors are positive. This information is to be used. And let us say f of x is equal to this quadratic equation. All right. And if you substitute x is equal to 1, then you will get A plus B minus 2C plus B plus C minus 2A plus C plus A minus 2B. If you see, all the terms will cancel and it will be 0. So we see that means 1 is a root of this quadratic equation. So 1 is the root of this given quadratic equation, but it is given in the question. We have another root because it is a quadratic equation. It will have 2 roots. So the second root is alpha not equal to 1. So given alpha not equal to 1 is the other root of the given equation. Therefore, this quadratic equation has 2 roots. One root is 1, the other is alpha, which is not equal to 1. then you can write sum of the roots and the product of the roots. But here we are interested in the product of the roots. So 1 and alpha both are the roots of the equation, and alpha into 1 is the product of the roots. Alpha into 1 is alpha. So alpha is equal to alpha into 1 is equal to the product of the roots is equal to, get into the quadratic equation, the product of the roots is equal to the constant term, that is c plus a minus 2b, by the coefficient of x square, that is a plus b minus 2c. So alpha is equal to this one. So note that the denominator, what you see here, a plus b minus 2c, and that you can split this as a minus c plus b minus c, and a minus c greater than 0. Why? Because c less than a, and b minus c is greater than 0. Why? C less than b. So because of that, a minus c greater than 0, b minus c greater than 0. Therefore, a plus b minus 2c is also greater than 0. That means the denominator, what you have, a plus b minus 2c, is greater than 0 because of the given condition. So we continue in the next slide. Right. Alpha is c plus a minus 2b by a plus b minus 2c. And the denominator, a plus b minus 2c, is greater than 0 for all values of a, given values of a, like this. Let us consider the statement 1. What the statement 1 says? If alpha, that is the root, one of the roots, belongs to minus 1 to 0, then b cannot be the geometric mean of a and c. Let's see the validity of the statement 1. So you take alpha belongs to open interval minus 1 to 0, meaning the meaning of that is minus 1 less than alpha less than 0. Write the value of alpha, that will be minus 1 less than, alpha is a c plus a minus 2b by a plus b minus 2c greater than 0. We have already seen the denominator is greater than 0, therefore multiply throughout. The inequality is not get disturbed, it will be maintained. And that will be equal to minus of a plus b minus 2c, we are multiplying by a plus b minus 2c, is less than c plus a minus b, that is the numerator, is less than 0. And the less than is maintained because it is positive. Agreed. Now you take the first one. This is minus of a plus b minus 2c less than c plus a minus 2b at one time. At the other time, you take c plus a minus 2b less than 0. So this is c plus a minus 2b less than 0 will give you c plus a is less than 2b. So this will imply c plus a less than 2b will imply b greater than a plus c. B greater than a plus c. Of course, you also have some information here, but it is the end, therefore we use this one. So b greater than a plus c by 2. What is a plus c by 2? It is the arithmetic mean of a and c. And you have a AM, GM inequality, arithmetic mean, geometric mean inequality, which says arithmetic mean is always greater than or equal to geometric mean. So this is greater than or equal to the geometric mean of a and c. What is the geometric mean of a and c? That is equal to under the square root of AC. Now b is strictly greater than the arithmetic mean. The arithmetic mean is greater than or equal to root of AC. So when you combine strictly greater than and greater than or equal to, you will get greater than, strictly greater than. This will imply b is strictly greater than under the square root of AC. But if b is a geometric mean of a and c, then b is equal to under the square root of a by c, AC, under the square root of AC. But here b is strictly greater than under the square root of AC. Therefore, b cannot be the geometric mean of a and c. So we are supporting the statement 1. So thus the statement 1 is true. So let's move to the next slide and we talk about the statement 2. Right. We have the alpha value and the other information. The second statement is if alpha belongs to the open interval 0 to 1, then B may be the geometric mean of A and C. So alpha belongs to open interval 0 to 1 means 0 less than alpha less than 1. That is 0 less than, write down the alpha value is less than 1. What we see, the denominator is always positive, therefore multiply throughout, then the inequality is not get disturbed and it will be maintained. That will imply 0 less than C plus A minus 2B is less than A plus B minus 2C. Right. And this is again give you two inequalities. So the first one, 0 less than C plus A minus 2B will give you 2B is less than C plus A. The second one will give you, that is C plus A minus 2B less than A plus B minus 2C will give you C less than B. But what we take this one. So this will imply now B is less than C plus A by 2. That implies B is less than C plus A by 2 is the arithmetic mean of A and C. So B may be the geometric mean of A and C. Why? Because the geometric mean is always less than or equal to the arithmetic mean. Now, B is less than the arithmetic mean of A and C. So, the geometric mean is less than or equal to arithmetic mean. Maybe B can be under the square root of AC, which will be strictly less than C plus A by 2. So, maybe B may be under the square root of AC, because B is less than C plus A by 2. This is the arithmetic mean, and the geometric mean is less than or equal to arithmetic mean. Therefore, B may be the geometric mean of A and C. Right. So that means we are saying the given statement 2 is also true. Thus, both the statements, statement 1 and 2 are true. So let's look at our options. Our conclusion that both the statements 1 and 2 are true appears against option 2. Therefore, the answer to this question is option 2. That is the detailed discussion of the solution of the problem, and it is definitely not an easy question. Not an easy question. I am sure you have understood the solution of this problem. We move to the next question, that is the 10th question. And it is about the sum of the series. It's about the sum of the series. The question has appeared in the JEE Main Examination held on 31st January 2024 in the morning shift. That is in the first session, in the first shift. Now, the given question is the sum of the series 1 by 1 minus 3 into 1 square plus 1 to the power of 4 plus 2 by 1 minus 3 into 2 square plus 2 to the power of 4 plus 3 by 1 minus 3 into 3 square plus 3 to the power of 4 plus etc. up to 10 terms. And we are given 4 options. So you are asked to find the sum of these series. Let's now discuss the solution of the problem in detail. To find the sum of these series. Right. So this series up to 10 terms. Let's now write down. So we want to find sigma r is equal to 1 to 10 TR, that is the rth term. So the sum of the 10 terms, where TR, the rth term, is equal to, now look at them, look at the terms. It is moving 1, 2, 3, the next one will be 4. Therefore, rth term will be r by 1, 1, 1. So 1 will be there. Minus 3 into 1 square, 3 into 2 square, 3 into 3 square will tell you 3 into r square. Plus 1 to the power of 4 plus 2 to the power of 4, 3 to the power of 4 will tell you r to the power of 4. So the term r is this one. So let's analyze term r still further. TR is this one. The denominator we have written as r to the power of 4 minus 2r square plus 1 minus r square. So we have adjusted 2r square minus r square is 3r square. the r to the power of 4 minus 2r square plus 1 in the denominator is r square minus 1 whole square minus r square is r whole square. So the denominator is looking like a square minus b square. So the factors are a plus b into a minus b. So that will be equal to r by r square minus 1 plus r into r square minus 1 minus r. So this is the factorization. The factorization is here. Now let us split this into the sum of the partial fractions. So these are well-known techniques what we normally do it, and that will be equal to 1 by 2 into 1 by r square minus 1 minus r minus 1 by r square minus 1 plus r. So if you take the LCM, you will get 2 by the product. So 1 by 2, 2 cancels. So this will be the sum of the partial fractions. Now this is when you write down sigma TR r is equal to 1 to 10, this will be telescoping series. So what is the telescoping series? If you expand it, the terms will be get cancelled, and what it will remain is the first term and the last term. So let's write down 1 by 2 into r is equal to 1. R is equal to 1 will be 1 by minus 1 minus 1 by 1 plus r is equal to 2. If you write down 1 by 1 minus 1 by 5 plus r is equal to 3. If you write down, this will give you 1 by 5 minus 1 by 11 plus so on and so forth. The 10th r is equal to 10. It will give you 1 by 89 minus 1 by 109. Telescoping means this 1 by 1 minus 1 by 1 cancels with plus 1 by 1. Minus 1 by 5 cancels with 1 by 5. Minus 1 by 11 cancels with in the next term 1 by 11, so on and so forth. Minus 1 by 89 cancels with plus 1 by 89, and leaving the first and the last term. That is 1 by 2 into first term is 1 by minus 1 minus plus minus 1 by 109. So both are minus. So take out the minus, that will be equal to minus 1 by 2 into 1 plus 1 by 109, and take the LCM. It will be minus 1 by 2 into 109 by 109 plus 1 by 109. That will be minus 1 by 2 into 110 by 109. After cancellation, you will get minus 55 by 109. That is the sum of the given series. Let's look at our options. So this is precisely option 2. Option 2. So the answer to this question is option 2, and that is the detailed discussion of the solution of this problem, and it is definitely an easy question. I am sure that you have understood the solution of this problem. We move to the next question, that is the 11th question. And this question uses both the concepts of arithmetic progression and geometric progression, and this question has appeared in the joint entrance examination main held on 31st January 2024 in the second shift. Agreed. The given question is, let second, 8th and 44th terms of non-constant arithmetic progression be respectively the first, second and third terms of a geometric progression. If the first term of the arithmetic progression is 1, then the sum of its first 20 terms is equal to, we are given 4 options. So we are given a non-constant arithmetic progression in which the second, 8th and 44th terms of this non-constant arithmetic progression is respectively the first and second and third terms of a given GP. So one is AP, the other is GP. It is given the first term of the arithmetic progression is 1, then the sum of its means the arithmetic progression's first 20 terms is equal to. Agreed? So we have to find that one. So let's now get into the question, discuss the solution in detail. Right. Let A is the first term and D the common difference of the given non-constant arithmetic progression. Right. Let's get into this. Second, 8th and 44th terms you have to consider. So, given T2, what will be T2 in arithmetic progression? A plus D. T8 is A plus 7D. T44 will be A plus 43D. Right. And it is given T2, T8, T44 are the first, second and third terms of a GP. That means that is T2, T8, T44 are in geometric progression. So if they are in geometric progression, it will be T8 square is equal to T2 into T44. That is the geometric mean. The square of the geometric mean is equal to the product of the first and the third terms. And that will imply T8 square is equal to T2 into T44. And T8 means A plus 7D square is equal to T2 A plus D into T44 A plus 43D. Now you are given A is equal to the first term, that is A of the arithmetic progression is 1. So let us take A is equal to 1, substitute in this. Now expand. So if you expand, this is what you have, the product of the factors, and simplify, you will get 6D square minus 30D is equal to 0. And 6D is common, 6D times D minus 5 is equal to 0. It will give you D is equal to 5 and D is equal to 0. And suppose you take D is equal to 0. D is equal to 0. If D is equal to 0, then it will be, all the terms will be A only, and thereby it will be a constant arithmetic progression. But in your question, it is given the arithmetic progression is a non-constant arithmetic progression. Therefore, we cannot take D is equal to 0. So, we reject it and we take D is equal to 5. Now we have to find the sum of its means arithmetic progression, first 20 terms. So, S20 is equal to, Sn is equal to n by 2 into 2a plus n minus 1 into d. And n is 20, a is 1, d is 5. Substitute in this. So, then you will get 20 by 2, that is 10, into 2 plus 20 minus 1, 19, 5s are, that is 95. So 2 plus 95 is 97 multiplied by 10, this is 970. Therefore, S20 is 970. Let's look at our options. Our answer 970 appears against option 1. Therefore, the answer to this question is option 1. And that is the detailed discussion of the solution of the problem that is given in the examination. And it is definitely an easy question. I am sure that you have understood the solution of this problem. Let's now move to the 12th problem. It's again a problem based on the concepts of arithmetic progression and geometric progression. The question has appeared in the JEE Main examination held on 1st February 2024 in the first session, that is in the first shift. The given question is, let 3 A, B, C be in AP. Right. And 3 A minus 1, B plus 1, C plus 9 be in GP. Then the arithmetic mean of A, B and C is, we are given 4 options. So you are given 3 A, B, C are in arithmetic progression, and 3 A minus 1, B plus 1, C plus 9 are in geometric progression. Then required to find the arithmetic mean of these 3 numbers A, B and C. Okay. Let's now get into the question. Right. So, given 3 A, B, C, they are in AP. Let D be the common difference of this arithmetic progression. Then the first term is 3, second term is A, that means 3 plus D. Third term is B, that is 3 plus 2D. C is 3 plus 3D. So this will be A is equal to 3 plus D, B will be 3 plus 2D, C will be 3 plus 3D. Now required to find the arithmetic mean of A, B, C. So A, B, C are in AP, arithmetic progression. Therefore B will be the arithmetic mean. So what will be B? So B is 3 plus 2D. So find out the value of D and substitute in this. Then you will get the arithmetic mean of A, B, C as B. Agreed. Now given 3, A minus 1, B plus 1, C plus 9 are in GP. Agreed. Agreed. This means 3. For A, you write 3 plus D minus 1. B plus 1. B is 3 plus 2D plus 1, comma. C plus 9. C is 3 plus 3D plus 9. Simplify. So this will be 3, comma. The second one is 2 plus D, comma, comma. The third one is 4 plus 2D, yes, comma. The fourth one is 12 plus 3D. They are in GP. These are in GP. So let's now concentrate just with these three terms. 3, 2 plus D and 4 plus 2D are in GP. Then 2 plus D square, that is the geometric mean square, is equal to the product of 3 and 4 plus 2D. So the 2 plus D is the geometric mean of 3 and 4 plus 2D. So that will give you 2 plus D whole square is equal to the product of 3 into 4 plus 2D. Now simplify and now simplify all that. You get D square minus 2D minus 8 product, and the factors are D minus 4 into D plus 2, and it will give you D is equal to 4 and D is equal to minus 2. So now we take D is equal to 4. So why do you reject D is equal to minus 2? Suppose D is equal to minus 2 you take and get into here. 3, 2 plus D, 4 plus 2D, 12 plus 3D are in GP. If D is minus 2, 2 plus D is 0, and as well as 4 plus 2D is 0. That means you will get 3, 0, 0, 6 are in GP, which is not true. They are not in GP. That is why we reject D is equal to minus 2. So now we got D is equal to 4, and what is required? The arithmetic mean of A, B and C. The arithmetic mean of A, B and C is A, B, C are in arithmetic progression. Then who is B? B is the arithmetic mean. So B is the arithmetic mean means B is what? B is what? B is equal to 3 plus 2D. So 3 plus 2D, that is equal to 3 plus 2 into D is 4, that is 11. So our answer to this question is 11, and it appears against option 1. So the answer to this question is option 1, and it is definitely an easy question. I am sure that you have understood the solution of this problem, and we move on to the next problem. The next problem is the 13th problem, that is the last problem. This question is from the arithmetic progressions, and this question has appeared in the JEE Main Examination held on 1st February 2024 in the second shift. Let SN denote the sum of the first n terms of an arithmetic progression. If S10, the sum of the first 10 terms is equal to 390, and the ratio of the 10th and the 5th terms is 15:7, then S15 minus S5 is equal to. So Sn denotes the sum of the first 10 terms of an arithmetic progression in AP, and we are given S10, the sum of the first 10 terms is 390, and the ratio of the 10th term and the 15th term, that means 10th term by is to 5th term is 15:7, required to find the value of S15 minus S5. Now we are given 4 options. Let's now discuss the solution of the problem in detail. Right. We have Sn. We are in an arithmetic progression whose first term is A, common difference is D, and the number of the terms are n. So Sn is given by n by 2 into 2a plus n minus 1 into d. Agreed? Agreed. So first we take a given S10 is equal to 390. So write down n is equal to 10 in the above one. Then it will be 10 by 2 into 2a plus 10 minus 1 into d is equal to 390. 10 by 2 is 5. 390 by 5 is 78. And this will be 2a plus 90. Let's call this as the equation 1. Now we are given the ratio of the 10th term and the 5th term is 15:7. That is T10 by T5 is equal to 15 by 7. T10, we are in the arithmetic progression, a plus 9d by T5, a plus 4d is equal to 15 by 7. Cross multiplying, you will get 7 times a plus 9d is equal to 15 times a plus 4d, and simplifying, you will get 8a is equal to 3d. So this is the second equation. Thus we have two equations in two unknowns a and d, and we know how to solve them. And on solving, we get a is equal to 3 and d is equal to 8. Right. Now a is known, d is known. So S15 and S5 can be found out and subtracted. So now S15 minus S5 is equal to 15 by 2 into 2a, 2 into 3 plus n minus 1 into d, that is 15 minus 1 into d is 8, minus S5, we have written the S5 here. So simplify, this is the simplification. The further simplification will lead you, ultimately you will get 15 into 59 minus 5 into 19. And on multiplication you will get 885 minus 95, and on subtraction you will get 790. Let's look at our options. 790 appears against option 2. So the answer to this question is option 2. That is the detailed discussion of the problems, problem number 8 to problem number 13 of the multiple choice questions that have appeared in the January 2024 session. I am sure that you have understood the solutions of all these problems, and I wish you all the best. Thank you.